Let's restart the session, numerical modeling. This is the session number 2, and Professor Assunção and myself, we will chair this second part of this numerical modeling session. So there are 5 presentations, but one is not here. Just to check, Marcel Ilha or Wagner Anabor, are they here, or someone will present for them? No? Last chance? No? Okay, so there will be 4 presentations, and as one is missing, so we have 15 minutes more, and we will split in 3 minutes for each presentation. So besides the 15 minutes, you still have 3 minutes as a bonus if you need them. Okay, the first presentation will be Model Intercomparison for Events Occurred at Santa Maria Sul Experiment. And this is a work done by Lia Martins Costa do Amaral, Cristiano Eichholz, Virginia P. Silveira. And this work will be presented by Lia Amaral from INPE, right? Thank you.
Okay, that's right. I will show you a brief analysis that we made. We made an intercomparison model for 2 precipitating events occurred in Santa Maria Sul experiment. Well, during the Chuva Sul campaign, the forecast was the main tool to decide which activities would to be developed at field. Then, as important component of the forecast, we have the prognostics from numerical models, and we analyzed the output models that Christopher showed before, the regional models, Brahms and Worth, with high resolution, spatial resolution. And we just decided to do a subjective analysis, just not to a point which was the best model, but just to see how was the performance of each model, if they were putting the precipitation before or after the time that the system occurred. And we analyzed just the precipitation data. We used the accumulated precipitation forecast from the Brahms with the best ensemble of CIPTEC, the Brahms with the best ensemble of NCEP, and Worth with the respective ensembles from CIPTEC, NCEP, and GFS. And we compared the accumulated precipitation from these forecasts with observed precipitation from INEMET, the National Institute of Meteorology, that has a good network, a large network of precipitation data. Well, we made the accumulated precipitation from observed data, precipitation data for 0 UTC, and we did the accumulated precipitation of 0 UTC from the output models. And we analyzed the 2 cases that the Renato showed before. It was the same case for the passage of frontal system in 1st December, and the mesoscale convective system occurred in 4 December. Well, here we can see the values of precipitation observed by INEMET network, And in the left figure, we have the highest values for passage of frontal system. We can see that the highest values are in extremely south at Chuy City, and Soledad with 73 millimeters, and Cruz Alta with 58 millimeters. And the precipitation observed in the passage of mesoscale convective system, we can see that the precipitation was located on the west part of state, with values nearest of 62 millimeters for Uruguaiana City, 42 millimeters for Alegrete, and 19 millimeters for Santiago. This was the highest values of precipitation of both systems. Now, here we can see on the left figure the output from Brahms Sepetec, and at right the Brahms and SEP for the frontal system on 1st December. Well, we can see relative to amount of precipitation, we can see in general both systems overestimated the precipitation, because here we can see that they put values near of 100 of millimeters, and the highest values observed was 73. We can see that in relation with the spatial distribution, we have a little, that they put a little of west, a little coverage of west on the relative to spatial distribution. And we can see an interesting thing that for Bagé City, that's here, was observed 1 millimeter of precipitation, and Brahms Sepetec didn't put any value, but the Brahms and SEP put values nearest of 50 millimeters, overestimating the precipitation for this specific location. But also models didn't put any value for Chuy City, that's here, the extremely south, that we had 68 millimeters of observed precipitation. And for the same event, we have the output from WRF Sepetec and WRF and SEP. And we can see that they also put overestimating coverage of rain, but the WRF and SEP put values greater than the previous, the Brahms, Sepetec and Brahms and SEP, and they put values greater than 100 millimeters for this west region. And for the Bagé City and Chuy in the extremely south, we can see that they put some precipitation on these both regions, but the nearest values of precipitation was from the WRF Sepetec, and the WRF and SEP put some overestimated the values from the both cities, that's here and here. For the 4th December, it was a passage of mesoscale system that comes from here was located over this part of the state that Renato showed some satellite images, and we can see that both models, also Brahms Sepetec and Brahms and SEP, located the precipitation over Uruguay. And for precipitation on the center of the state, they put just some field convective cells, but they don't represent the precipitation that was observed. In the WRF Sepetec and WRF and SEP, we can see that they also put the coverage of precipitation over Uruguay, but we can see that WRF and SEP put a major coverage and with highest values, but they cover a little part of the west part of the state, and we had approximately some precipitation, like at Uruguaiana, the model underestimated the precipitation, comparing 10 millimeters to 62 millimeters. And for Quaraí, it was approximately the same, with the 20 millimeters of precipitation for comparing with 22 millimeters of observation. And for Santana do Livramento, it's the same region, it's like here, we had the models overestimating the precipitation. And we had also the output from WRF with the best decimal of GFS, and for the both systems, the passage of frontal system on the left, and we can see that the spatial distribution was similar of the previous models, overestimating the coverage. But here we can see that the values of amount of precipitation was greater than WRF CPTEC and less than WRF INSEP. And for the system for December was the same thing, with a coverage similar with the WRF INSEP, but with values of amount of precipitation greater than CPTEC output and less than WRF INSEP. Then we realize that for the frontal system, greater than WRF CPTEC and less than WRF INSEP. We just analyzed for these two cases, then it's just specific analysis, then we can talk what is the best, and isn't our objective, but it was just to see how was the performance of different systems, distinct systems, like frontal system and mesoscale convective system. That's all. Yeah, this outputs, it's the same that Christoph showed before. It's 2 kilometers of spatial resolution of each model, both the WRF and Brahms, but each model with the best output of ensemble. And yeah, yes, the same resolution for both. No, I got some analysis, but for another days when I was at Santa Maria, isn't for these two cases, just for the case before, and we didn't analyze for the specific days.
So perhaps good idea to use something like estimation to see if the patterns match with the model.
With the model from mesoscale.
And the other question is, you use the in-bed data. Is it 24 hours recommendation?
Yes.
Because 24 hours recommendation ends 12.
Yes, we discussed about this question because generally the output from models is for 12Z, but the network of NMAT has the accumulated precipitation of 0Z. Then we made the accumulated precipitation for the models for 0Z. We got the outputs. Yes, we discussed between us, then what is the best, then the people decided to 0Z.